The global logistics and warehousing industry is undergoing unprecedented structural change. Rapid e-commerce growth, urbanization, and increasing supply chain complexity are transforming facilities from simple storage sites into highly automated, advanced fulfillment centers. This shift has driven higher and denser racking and the adoption of robotic automation while simultaneously creating new risk conditions where conventional fire detection and suppression approaches are no longer sufficient. This report analyzes the physical and technical limitations of traditional fire detection technologies, for example, spot-type smoke detectors and photoelectric beam detectors in modern logistics environments, and proposes fiber-optic distributed temperature sensing (DTS) as a strategic alternative. In particular, the rapid increase of high-risk assets such as lithium-ion battery storage together with tighter international regulations like NFPA 855 and IFC 2024 is accelerating a shift from detecting smoke to tracking, heat, and real-time temperature change. Industry statistics indicate that after a major disaster, about 40% of affected businesses never reopen, and an additional 25% shut down within a year. This highlights that fire safety is not only a compliance issue, but a core pillar of business continuity planning (BCP). This proposal presents a comprehensive technical and business roadmap to protect logistics assets, reduce insurance and maintenance costs, significantly improve total cost of ownership (TCO), and ultimately ensure uninterrupted supply chain operations. We propose a fiber-optic distributed temperature sensing (DTS) system as the optimal solution to address these issues. DTS uses the optical fiber cable itself as a long, continuous temperature sensor, enabling real-time monitoring of the temperature distribution along the entire length spanning several kilometers. In modern logistics centers, racks are getting taller and denser, and that vertical growth creates a dangerous fire paradox. Between rack rows, the narrow, flue spaces act like chimneys. If a fire starts, heat and flame can race upward through these channels in seconds faster than traditional systems were designed to handle. That's why legacy detection is breaking down. First, ceiling-mounted beam detectors struggle in high-bay buildings. Near the ceiling, a hot air layer, what we call a thermal barrier, often forms from solar heat or heating systems. Early-stage smoke at floor level frequently cannot penetrate this layer. Instead, it spreads and accumulates at mid-height, a phenomenon known as stratification. The result is simple but alarming. Smoke can fill the warehouse while ceiling detectors remain silent. And there's another issue: structural movement. Large steel frame buildings can shift slightly. That movement can misalign the beam path and cause frequent nuisance alarms. Second, consider aspirating smoke detection (AST). In clean environments like data centers, AST is excellent. But in a dusty warehouse, it can become a maintenance nightmare. Cardboard dust and tire particulates clog filters quickly, forcing frequent service, often with aerial lifts and high labor cost. Even worse, in huge open spaces, smoke gets diluted. The concentration drops, detection slows down, and the alarm comes late. Dense racks and constantly moving robots add one more problem. They physically block smoke from traveling to detectors. So by the time sprinklers activate, the fire can already be out of control and the facility may face catastrophic asset loss. Now, there's an even more serious risk factor: lithium-ion batteries. As warehouses store more ESS modules, EV components, and battery-powered tools, fire risk moves into a completely different category. The key mechanism is thermal runaway. When a cell's internal temperature rises, the separator can fail, triggering a chain reaction of intense heat generation. In a very short time, temperatures can exceed 1000 degrees Celsius. Here is the critical point: smoke is a lagging indicator. In the early stage of thermal runaway, there may be little to no smoke at all. So when ceiling smoke detectors finally react, the fire may have already spread to adjacent cells, pallets, or an entire rack bay. This is why traditional smoke-based detection becomes too late by design. Global regulations are responding. Standards such as NFPA 855 and the latest editions of the International Fire Code increasingly emphasize early detection and risk mitigation before propagation. In other words, the detection paradigm must shift from smoke to direct tracking of heat and temperature changes inside the racks. So what is the answer? This proposal introduces fiber-optic distributed temperature sensing (DTS). DTS is powerful because the fiber itself becomes the sensor. A single fiber-optic cable can act like thousands of temperature sensors, continuously measuring temperature along its entire length. The system sends laser pulses through the fiber and analyzes the returning light, using Raman backscatter to calculate temperature and identify the exact location of abnormal heat in real time, down to meter-level resolution. The biggest advantage is installation. With DTS, you can route the fiber directly along rack structures or sprinkler piping right where heat begins. That means detection happens close to the ignition source, often within centimeters. This approach bypasses the limitations of ceiling-based smoke detection. Stratification doesn't matter. Smoke, flow, obstacles don't matter, because we're measuring heat directly at the rack level. And DTS is not just an alarm. It provides temperature trend data. For example, Zone A is 25 degrees and rising at 2 degrees per minute. That rate of rise intelligence enables early warning even before a fixed threshold is reached, helping detect abnormal heating at the pre-runaway stage. Compared to traditional linear heat cables, DTS is also more resilient. Heat cables often must be replaced once they melt, but if the fiber remains intact, DTS can be reset and reused. It's non-corrosive, immune to electromagnetic interference, and designed for decades of service life. Now, let's talk about what matters for operations and executives: cost and efficiency. The right metric is total cost of ownership (TCO), the sum of CAPEX and long-term OPEX. Aspirating systems often require complex piping and frequent filter replacements, especially in dusty environments. Over time, maintenance costs grow significantly. DTS is different. You invest in the controller and fiber installation, and after that, ongoing maintenance is minimal. There are no filters to constantly replace, and no routine high-elevation service work. Operationally, DTS is also extremely flexible. Through software, you can define thousands of virtual detection zones without rewiring. These zones can be mapped one-to-one to existing sprinkler zones, enabling targeted suppression and reducing water damage. Commissioning becomes simple. You don't need smoke tests that disrupt warehouse operations. A localized heat source is enough to confirm performance at any time. And DTS can deliver more than fire safety. It can identify cold air leakage in refrigerated areas and detect overheating in motors and conveyors early, enabling predictive maintenance. So DTS becomes a safety system and an operational intelligence tool at the same time. At the end of the day, this is about one thing: business continuity. Fire safety is no longer just a regulatory requirement. It is a survival requirement. DTS provides early warning at the abnormal heat stage before escalation, securing the golden time operators need to intervene, isolate a rack bay, and prevent a full-scale disaster. And now detection must change from smoke to temperature. Fiber-optic DTS is the most reliable and strategic investment to protect assets and keep supply chains running without interruption. It also strengthens your position in insurance negotiations. A high-performance early detection system for lithium-ion risks can improve risk ratings and potentially reduce premiums. The logistics industry has changed. The hazards have changed. And now detection must change from smoke to temperature. Fiber-optic DTS is the most reliable and strategic investment to protect assets and keep supply chains running without interruption.